Oh, hey, there you are. Broke Dad Builds. Do you want to learn more about series and parallel circuits, or you don't know about them and you want to figure out what they're about and how they work and how voltage and resistance works on those type of circuits, because you want to build your own harness or wire something up and make sure you do it the right way and not burn something up? Well, in episode 2 of our Automotive Electrical Series, we're going to be going over just that, series and parallel circuits. So stick around and let's learn a thing or two about them. Hi, I got a lot of stuff. We're going to go over it. Series and parallel circuits. We're going to learn what series circuit is and what parallel circuit is, and kind of discuss the calculation and how to figure out voltage, and then how much resistance you need, and figure out, you can calculate how many amps that you're going to have going through a circuit. So in a series circuit, like we talked about before, it's a single circuit that is one single flow or path for voltage to follow to go to a load and the ground, like this one. Here's our battery right here, and this is what it'll look like on a wiring diagram, schematic. Your battery, 12 volts, negative to the ground, common ground, positive, and your positive side of the circuit going to the load, going to the ground, the switch on the ground side. And we got a resistor, and we don't know what amperage rating this resistor or this fuse is. Excuse me. So we got to figure out what the fuse rating is for this circuit, right? So before we start really deep diving and stuff, we'll talk about Ohm's law. You're going to need to know that, if you're going to be building your own circuits or harness or anything like that, where you're going to have voltage and load and all things like that. You need to figure out, or at least know Ohm's law, which is E over I times R, which is volts for E. I is amps or current times R, which is resistance. So if you keep this in mind, if you're trying to figure out how many amps is going through this circuit, or if you want to figure out how many ohms resistance a light bulb is, you just plug the values in like this. And for this example, we're going to figure out how many amps or what amperage fuse that we should use on this circuit, for this series circuit. If we measure the bulb, we can say the bulb is, let's say, 6 ohms resistance. And we know that the battery voltage is 12 volts. Well, for this, we're going to follow Ohm's law. Volts, we already know volts, which is 12. And then 6 ohms, so volts over R. So 12 divided by 6 equals 2. So we need at least a fuse that's a 2 amp fuse, which they don't make 2 amps, but we'll say 5 amp fuse, right? 5 amp fuse. So you'll need a 5 amp fuse, and then this is at least delivering 5 amps to the bulb. Now, this is a series circuit. We talk about parallel circuits. That's going to be when you got battery voltage on one branch, one wire, that gets split to 2 different loads or more than 2. So then each load will get battery voltage applied to it. And they can have a common ground, which it's the chassis ground. They can have their own grounds that go to a ground-sided control switch. They can go to a single switch. They can go to a relay. They can go to anything. They can go to the ECM, where the ECM or the PCM will control the ground side of the switch for the load, for like a stepper motor or a light or whatever it might be. Well, if we want to figure out resistance, or we want to figure out the amperage, the rating that we need, in order to figure out the amperage rating, we need to know what the total resistance equivalent is for this circuit, for a parallel circuit, right? And we can't just add these together. We can't say, oh, 6 plus 6, it's going to be, that's 12 volt or 12 ohms of resistance on this circuit for this parallel circuit. It doesn't work like that with parallel circuits. With parallel circuits, when you add a resistance to each branch on that parallel circuit, each resistance added together in parallel decreases the total resistance in the circuit. So to go over resistance equivalent, if we're going to calculate what the total resistance is, or the resistance equivalent is in this, we want to follow a formula, which you could do this, where you go R1 times R2 over R1 plus R2. So if we do this, that's 6 times 6, that equals 36, over 6 plus 6, which equals 12. 36 divided by 12 equals 3. So our resistance equivalent for this circuit is 3 ohms. So with that being said, we already know how to calculate what amperage is, right? So with 3 ohms, we'll do 12 over 3 equals 6. Or excuse me, yeah, or 2. Or, I'm sorry, 4. My math's not mathing, and my brain's not braining. So 12 divided by 3 is 4. So that's 4 amps that's going to these bulbs. That's going to be used by these bulbs. So it takes 4 amps to illuminate these 2 bulbs, 6 ohms resistance each. And it's another thing to keep in mind is that when you have a parallel circuit with multiple loads, multiple resistances, your amperage is going to increase because it's going to require more amps to supply the more voltage and amps to supply each load at the 12 volts that's at the source. Does that make sense? I hope it does. So we already know it's 4 amps, so we still have a 5 fine amperated fuse that we need for that. So now that we've understood the basics of a series and a parallel and Ohm's law, let's go and let's look at it in real life with an example. Here we have a series circuit. We're going to just say that our battery is over here on this side. We have our positive side going to our fuse, coming out of the fuse, going to the load, and then we'll just have an imaginary switch here. And that switch will be going to ground. So in a series circuit, think of it being a single path. Single path that goes from source, load, ground to make a complete circuit. So if we take this ground wire, go into the battery negative, and we want to make a complete circuit, and imagine that we have a switch. Once we close that switch, the light energizes, consumes the voltage potential that's being supplied to it, and then you have the complete circuit going back to ground to the battery. Open the switch, opens the circuit, the light is no longer illuminated. So now we have a series circuit. Now we're going to look at what a parallel circuit looks like. All right, now we're set up with a parallel circuit. Parallel circuits can be pretty simple. You have a series to a parallel. So you have one single positive circuit supply going to two different loads that are split up. So the loads are sharing a single power source on that circuit, and then they go out to a common ground, which for this case, we're just going to say that this ground right here is going to be the common ground. So when you have a series, or when you have a parallel circuit, each load will be getting the supplied voltage from the battery. And when you power it on, they both will be getting battery voltage. Now you can have a switch for each one, and just say when that switch closed, it lights up. When that switch is closed, it lights up. Or you can have a relay. You can have a relay control the lights. So when the relay is energized, it closes the switch inside the relay to complete the circuit for each light. So if you think of like a brake switch or like turn signals, it uses relays and blinkers to be able to cycle the lights on and off. Now what about if you have more than one load in a series? Well, then you start getting to issues where this could be an example of if you have like a excessive resistance on a circuit, like on a series circuit, right? If you got like tons of rust or corrosion on the ground side connection that's, going to the chassis ground, or bad switch, or switch that has tons of corrosion on the contacts, anything like that, right? Depending on the resistance for each load, if you have the load on the last part of the circuit, that's going to be the one to use as most of the available voltage going to it, the current going to it. So if you power this up, you'll see that only this one is lighting up, but this bulb is not lighting up. So if you keep this in mind, voltage goes to the path of least resistance, right? So it's going to go through here, and then when it gets to the last part of the resistance in the circuit, it's going to illuminate this bulb. This bulb's going to consume the available voltage that's left going through the circuit, and then it lights up, and then you have the complete circuit going back to the ground, to the battery. You can also think of this as if you get, like again, excessive resistance on the circuit after the load, we can just say this is the resistance corrosion buildup on the ground side. You're gonna have issues where things don't work. So this is the corrosion, the bad ground connection that's using up available voltage, right? It's going to go to this, and this is going to cause the light to not illuminate. But then when you clean your ground, you clean connections, all your voltage will go to the light or the load. So to go over the loads in a series circuit a little bit more, we're going to bust out the multimeter. We'll go through a multimeter in more detail later, just so you can know how to work one in more depth. But for this instance, we're just going to go through the theory, talking about resistance in the loads, especially like if we talk about these light bulbs. And we're going to say, let's put this meter on the resistance setting on standard range. And if we check the resistance, that's got 38.2 ohms of resistance for this little bulb. And then if we check the bigger bulb, .4. So this has the least amount of resistance in this circuit that we're looking at. So the voltage will go through this, like we seen earlier, and then the bulb, after this load, will be the one to consume all the resistance. And what happens is that when it does, it releases light, and that's a form of energy, just another form, and that produces heat, and then it gets consumed. The voltage gets consumed and goes back to ground. So just keep that in mind when you're looking at these circuits, right? All right, and to kind of wrap things up and start touching on relays a little bit, I got a relay. This relay is more of a standard relay. It's a 12 volt relay. It's a 30 amp relay. And this one, it has two positions that it can supply power to, right? Pin 30 is the supply voltage to the switch side of the relay. And then you have 87A, which is the normally closed portion of the relay. And then 87, which is the normally open. Whenever this relay is energized, it will change the position of the switch inside it from 87A to 87. So for things like this, you know, this could be like a starter, goes to a starter solenoid for an ignition switch, where you energize it to control the higher voltage going to the starter, to the Bendix. But for this, we can also do it for lights, you know, for headlights, right? So if we energize 86 and 85, which I have it hooked up to this, and we supply battery voltage to 30 on the relay, it's going to energize this switch inside the relay, close that switch to pin 87, and then that will supply voltage to the lights. So if we take supply voltage and we're going to put it on the ground side for pin 85, just listen. That's it, the switch on the inside of the relay energizing. Now, if we put this, let's say we have our common ground, which we'll just use this as the common ground. And then we supply voltage to the relay, which in turn has voltage at pin 30, waiting to go to pin 87. We close that relay or open it, however you want to say it, because you're technically opening the contact from 87A to close on 87. Makes contact inside the relay, and then allows voltage to go to the load, to the lights. And there's ways to check the relay too. If you know the position for each one, you can check continuity between 30 and 87A. If you have continuity there, you know it's good. If you have an open between 30 and 87, you know that's good. Sometimes the contacts within the relay itself can get pitted due to arcing, and that can cause them to not have continuity and not make connections. And there's also like relay testers you can get, but we'll go into relays a little bit later on in the next video. But just another way to visualize and think about series circuits, even parallel circuits. This could be used in a parallel circuit where you can have alternating supply voltage. Again, you can have one relay powering two separate loads, like these lights, which I'll do that here in a second. All right, so if we think about having this relay, let's say for a brake switch, right? So you have power going to pin 30 on the relay. Pin 30 goes to 87A, which is normally closed. That's why this light is on, because this light is on that part of the circuit. And then once the relay is energized, it opens 87A, closes to 87. So if you think about a brake switch, you know, brake on off switch, you have your running light. You can think of that. And then when you apply the brake, turns the brake light on. Or normally brake switches, they're normally closed and then they go open, but they still same kind of principle, just alternating voltage across the circuit, or like a turn signal, right? Or anything, right? So there you have it. Pretty simple stuff. We'll go into the relays again later on, and let's go back to the drawing board and talk more there. Hey, and that's it for episode 2 of series of parallel circuits and just overall circuit review for this Automotive Electrical Series. Stay tuned for episode 3, which is going to be coming out, I think, as soon as I can. That we're going to go in more depth with fuses, relays, ground control side of circuits, just building on that foundation. And then once we get to episode 12, you're going to be like a wizard, magician of electrical circuits and diagnosing and troubleshooting things. So if you find this helpful, let me know in comments. Provide stuff in the comment section. Good, bad, indifferent, I don't care. Just let me know. And share it. Hit the notification icon. If you haven't subscribed yet, I would greatly appreciate if you did. It helps the channel out tremendously. Helps me build the channel more, because without your support and feedback and subscribing and commenting, I'm not going to be able to do a whole lot with the channel. So I appreciate it very much. And stay tuned for the next episode and check out the next video. Have a good one.